April 11th, 1970. It's a beautiful Saturday at Kennedy Space Center, and the world is watching as Apollo 13 sits on the pad. Now we all know this mission as the successful failure, but what's wild is that the drama didn't start with the oxygen tank explosion. It started almost immediately after liftoff. Everything looks smooth for the first few minutes, but as Saturn V is screaming through the atmosphere, something goes wrong. We're talking about the second stage, the S2. About 5.5 minutes in, the center engine starts vibrating. It actually experiences something called pogo oscillation. Basically, the engine is bouncing up and down so violently, it's at risk of tearing the whole rocket apart. To save the mission, the computer senses the pressure drop and shuts the center engine down nearly 2 minutes early. Now imagine being the crew. You've just lost 20% of your thrust while you're still fighting gravity to get into orbit. In most cases, that's a mission ender. But the Saturn V was a beast of a machine. The onboard computers scrambled to compensate. The 4 outboard engines realized they had to pick up the slack, so they burned an extra 34 seconds to make up the lost velocity. It was a close call, but it worked. They managed to reach a parking orbit, performed a perfect translunar injection, and began their coast towards the moon. At this point, Jim Lovell and his crew probably breathed a massive sigh of relief, thinking the scary part of the mission was behind them. Little did they know, they were only 56 hours away from a much bigger problem. For the next 2 days, Apollo 13 was actually a bit of a boring mission. The crew was relaxed, the trajectory was dead on, and they were making great time towards the moon. In fact, they just finished a live TV broadcast where they showed off the lunar module. They were upbeat, joking around, and ready to settle in for the night. But about 9 minutes after the broadcast ended, at roughly 56 hours into the mission, everything changed in a heartbeat. Houston radioed up a simple, routine request.
You get a chance, we'd like you to stir up your cryo tanks.
That
In addition,
XCW audio
shaft
shirt.
and canyon,
I missed it.
or look at the Comet Bennett if you need it.
See, the liquid oxygen tanks tended to settle and layer, which makes the gauges inaccurate. To fix this, they just had to flip a switch to turn on some internal fans. Basically a high-tech smoothie blender for the oxygen. Jack Swigert flipped the switch, and seconds later, a massive bang rocked the entire spacecraft. This wasn't like the movies where everything explodes in slow motion. It was confusing. Master alarms were screaming, the computer was rebooting, and the ship was shuddering. This is when Jim Lovell came on the mic and delivered the line we all know today.
Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem. We've had a main B plus undervolt.
Roger, main B undervolt. Okay, stand by, 13. We're looking at it.
At first, the guys in Houston thought it was a sensor glitch. They couldn't believe what the data was telling them. But then, Lovell looked out the left-hand window. He saw a gaseous substance venting at a high rate into the vacuum of space. That was their life support. That was their oxygen. In that moment, the mission changed from a lunar landing to a desperate race against the clock. They weren't worried about the moon anymore. They were just trying to figure out how to breathe long enough to get home. Down in mission control, the flight controllers are staring at their screens in disbelief. Pressure in oxygen tank 2 is at 0. Tank 1, it's dropping fast. This wasn't just a glitch anymore, the Odyssey was bleeding out. Gene Kranz, the legendary flight director with the white vest, makes the call that changes history. They have to shut down the command module to save what little power they have left for re-entry. But if they turn it off, how do they stay alive? The answer was the Aquarius, the Lunar Module. Now keep in mind the LM was designed to hold 2 people for about 2 days. Now it had to act as a lifeboat for 3 men for 4 days. It was a frantic, high-stakes move. They had to power up the LM while simultaneously killing power to the command module. If they didn't get the alignment data transferred from one computer to the other before the power died, they'd be lost in space, unable to navigate. Once they moved into the lifeboat, things got miserable fast. To save every drop of battery, they turned off almost everything. No heaters, no luxuries. The temperature inside plummeted to just above freezing. The walls started to drip with condensation. Their food turned into cold, unappetizing mush, and sleep was almost impossible due to their constant shivering. But the cold wasn't their biggest threat. It was their own breath. Since the LM was only built for 2 people, the scrubbers that filtered out the carbon dioxide couldn't keep up with 3 men. The CO2 levels started hitting the danger zone. They had plenty of spare filters in the command module, but there was a catch. The ones in the command module were square, and the holes in the lunar module were round. This led to one of the most famous moments in engineering history. Houston literally gathered a bunch of engineers in a room, dumped a pile of the exact scraps and tools the astronauts had on board, and told them, "Find a way to fit this square peg into a round hole, or they're going to suffocate." And using nothing but plastic bags, cardboard, and a whole lot of gray duct tape, they actually did it. At this point, Apollo 13 is behind the moon. They're in the dark zone, totally cut off from Earth. Now usually this is where astronauts get that iconic view of the lunar surface. But Lovell and his crew didn't care about the craters. They were focused on one thing, the free return trajectory. They had to fire the lunar module's descent engine, an engine never designed to be used in deep space, to slingshot themselves around the moon and head back towards Earth. If that engine didn't fire perfectly, they'd either crash into the lunar surface or go sailing off into a permanent orbit around the sun. The engine roared to life, it held steady, and they were officially on their way home. But home was still 250,000 miles away. The trip back was a nightmare of endurance. They were dehydrated because they had to ration water, and they were exhausted from the lack of sleep. As they approached Earth, they had to move back into the dead command module, which was now just a cold, damp tin can. When they turned the power back on, they were terrified the condensation on the wires would cause a short circuit and start a fire. Remember, a fire is what killed the Apollo 1 crew. But thanks to some extra thick insulation installed after that disaster, the ship stayed dark, quiet, and thankfully not on fire. Then came the re-entry. When a spacecraft hits the atmosphere, the friction creates a plasma shield that cuts off all radio communication. Usually this blackout lasts about 3 minutes. People in mission control were staring at the clock, holding their breath. 3 minutes passed, silence. 4 minutes passed, still nothing. The world thought they were gone. The heat shield was damaged in the explosion and everyone feared it would just crumble, incinerating the crew in seconds. But then, through the static, a faint voice cracked over the radio.
Okay, so
The splashdown. The parachutes deployed and the Odyssey bobbed in the Pacific Ocean like it belonged there. They didn't land on the moon and they didn't get their moon rocks, but what they did do was survive the most hostile environment known to man through pure collective genius. It wasn't a mission of discovery, it was the greatest rescue mission in human history.